Okay, so in this video we're going to learn about inverse trigonometric functions. So let's talk about the inverse of sine. For those familiar with inverse functions, you know that a function cannot have an inverse if it does not pass the
horizontal line test.
line test, which sine doesn't. But if we restrict this sine's domain to negative pi over 2 and pi over 2, we get something that could give us a inverse function. And this is what it looks like on a unit circle. If it was restricted from pi over 2, over 2, that would be the domain. So we can get inverse of this. We just simply reflect it over the line, and that's how you normally get inverses, and we get something like, something more like this. That would be the inverse of sine. So that's the same concept can apply to every trigonometric equation. So cosine, inverse of cosine, it doesn't pass the vertical line test, which restricted to pi over 2, negative pi over 2, and pi over 2. It would look something like this, and the inverse of that would look like this. And what this domain does right here, pi over 2 and pi over 2, would mean that it would only give you values that are in that are in its domain. So say you want to find the inverse of sine of square root of 3 over 2 equals theta. Because inverses they take in the side to find the angle rather than the angle to find the side, as in a conventional equation. So 3 over 2, that can be over here or over here. But since the domain of an inverse function is pi over 2 of a sine inverse function to negative pi over 2, it would only spit out pi over 6, value right here, rather than. That's a brief introduction into trigonometric equations. Let's get a little bit more in depth into. So these are all of the inverse trigonometric functions graphed. There's sine, inverse sine of theta, inverse cos of theta, inverse tan of theta, inverse cosecant of theta, inverse secant of theta, and inverse cotangent of theta. Another way to say, instead of saying inverse of all these trigonometric functions, you can simply say arc of sine, or arc of cosine, or arc tan, or arc cosecant, and that would mean the same thing as inverse of whatever function. Okay, so let's do some work involving inverse functions. So arc tangent of 1. Another way you can write that is tangent of theta, and in this non-inverse way, tangent of theta equals 1. So where on the unit circle does tangent equal 1? Well, here and here. But since the domain of tangent is pi over 2 and negative pi over 2, we know that what they're speaking about is right here. And the angle right here is pi over 4. So arc tangent of 1 equals pi over 4. Now let's do the same thing to arc sine. Alright, so we can rewrite it as sine of theta equals 1/2. Well, where on the trigonometric where on the unit circle is sine equal to 1/2? The value is pi over 3, and we don't even have to bother that because we know that the domain is pi over 2 and negative pi over 2. So we know that arc sine of theta equals -1 is actually sine of pi over 3 equals -1. So arc sine of 1/2 equals pi over 3. Let's do arc cosine of 1/2. Cosine of theta equals 1/2. That's what we have to rewrite it as. Alright, cosine of what equals 1/2? Well, cosine is 1/2 only on this side of the graph. So it's 1/2 at pi over 6. That's 1/2 at negative pi over 6. Sorry, it's negative 1/2 here. What am I talking about?